Hello, my name is Bernice Tan, and today my group would like to talk about the applications of 5G and beyond 5G in the use of smart ports. Before we begin, what is a port? A port is where ships can dock to load and unload cargo. Over 95% of traded goods are transported by water, making ocean shipping the primary mode of transportation for international trade. However, ports struggle with many issues, such as the increased cost of labor, unfavorable working conditions, shortage of staffs, and congestion. To combat these issues, ports have turned to automation as the primary strategy to reduce cost and improve efficiency. Next, we'll look into what is 5G. 5G is the fifth generation mobile network designed to connect virtually everyone, including machines, objects, and devices. 5G wireless technology delivers higher multi-gigabytes per second peak data speeds, ultra-low latency, more reliability, massive network capacity, and increased availability. Higher performance and improved efficiency empower new user experiences and connects new industries. The combination of both makes up a smart port of the future. How, you may ask? Well, smart ports require communication systems to support low latency, high bandwidth, and high reliability communication services. With legacy communication based on optical fiber and Wi-Fi, network deployment, operation, and maintenance are costly. 5G is expected to address such challenges thanks to its low latency, large bandwidth, and capacity. It also offers an end-to-end application performance guarantee.
As we know that 5G has many use cases in smart ports, such as improving port traffic management with a reliable and resilient network. This results in better traffic flow. Traffic light can be connected to the port's central road traffic control management through the 5G mobile network with a dedicated network slice. The 5G slice for the control unit has very high reliability, as a failing connection to the central road traffic control management would stop the proper operation of the traffic light. Currently, every traffic light in a port area is connected via fiber. However, 5G shows that a safe and reliable connection is possible. Modifying existing or installing new or temporary traffic light would become much easier, faster, and economically efficient. Next, improve port operations using 5G technology and virtual or augmented reality. Engineers at the port can use augmented and virtual reality AR, VR to help with their day-to-day work. The technology allows easy mobile access to construction plan, building information and other technical installations on templates or Google's within the port area. This AR and VR equipment is connected to a central application server through the 5G mobile network using a dedicated network slice. A 5G smartphone will enable connectivity via WLAN tethering to the goggles and tablets. Furthermore, with intelligent automation, the efficiency of the port can be achieved, which will also help communication between different parties on the spot. Smart ships are equipped with the sensor to monitor the position of the ships and environmental data in real time. These sensors must be connected to a 5G base station via a 5G customer premise equipment 5G CPE wireless terminal. Moreover, smart guided vehicle must replace conventional trucks with smart guided vehicles to improve safety and port efficiency due to their ability to consume fewer resources. SGV needs to be equipped with sensors and high-resolution cameras. The existing 4G network cannot meet the low latency requirements of SGV. Still, it can be achieved by implementing the 5G network. In addition, geofence asset tracking and condition monitoring can be performed using the 5G Internet of Things. Good containers and pairs can be tracked within the 5G network and between them using a public network. The containers are also equipped with sensor measuring temperature, light, humidity, and more. transmitting this data in real time to a user dashboard. This level of facility is expected to become critical in modern free port scenario, where products can move customs free between a central port zone and remote free zones up to 45 km away. Automated drone surveillance and emergency response. The project used the reliability and bandwidth offered by 5G to test automated drone perimeter inspection and incident response at the port. Security for goods and workers is paramount in the port environment, which can span large areas. Additionally, AI-enabled predictive maintenance. Queue cranes are one of the most critical assets in a port. Unexpected disruptions can lead to stoppages in loading-unloading operations, affecting vessel turnaround times. This project is monitoring the condition of the critical components of the 5 cranes using low-cost load sensors communicating via 5G technology. Artificial intelligence is employed to identify pre-disruption triggered events to guide the predictive maintenance strategy. Lastly, remote control of yard cranes such as 5G provides critical latency and throughput capabilities to enable the crane critical operating system to operate and to transfer the multiple CCTV feeds that the operator requires. Remote control of access is essential to the port for health and safety by removing operators from the queue and attracting a wider pool of employees.
Next, I'll be talking about 6G and what it improves compared to 5G. The 6G standard will be a next-generation communication standard. Two key drivers for building 6G are increased speed and lower latency. It will use more advanced radio equipment and greater volume and diversity of airwaves than 5G, including an extremely high-frequency spectrum that delivers ultra-high speeds and massive capacity over short distances. This results in 6G being 50 times faster than 5G, 100 times more reliable, and offers broader coverage. It will operate on terahertz bands from 100 GHz to 10 terahertz, delivering a peak data rate of 1000 gigabits per second with air latency lower than 100 microseconds. Along with lightning fast speed will come extreme reliability. No more lost connections, timeouts, or pixelated video calls. 6G will expand the scope of capabilities to support new and innovative applications in wireless connectivity, cognition, sensing, and imaging. Sensing is the basis for all interaction with an emulation of the physical environment. 6G will propel the fourth industrial revolution, mainly enabled by the Industrial Internet of Things services integrated with AI and machine learning.
Next, we will take a look at the technical side of 5G. Depending upon the direction of data to be processed, the 5G radio protocol stack has two categories: control plane stack and user plane stack. In the control plane stack, if the data type is signaling or controlling the message, then it is forwarded through the control plane. Whereas, if the user plane stack, user data is sent through the user plane. Both the control and user plane stack have the standard structure for physical medium access control, radio link control, and packet data convergence protocol layers. Compared to the typical OSI layer, the 5G protocol layer consists of an open wireless architecture layer, network layer, open transport layer, and application layer. The open wireless architecture layer functions as a physical layer and data link layer of the OSI stack. The network layer routes the data from the source IP device to the destination IP device and is divided into lower and upper network layers. The open transport layer combines the transport layer functionality and the session layer. The application layer marks the data as per the proper format required. It also does encryption and decryption of the data and selects the best wireless connection for a given service. All this results in 5G being very efficient. Massive MIMO antennas are characterized by an ultra-integrated design. They concentrate the power amplifiers, whose efficiency has been improved compared to 4G, at the antenna shelter. One of the most significant developments associated with 5G is the widespread use of deep sleep modes. The basic principle is simple: to selectively turn off one or more devices in the absence of traffic. 5G allows transmission-free time slots to be configured in non-traffic conditions to activate more advanced and energy-efficient sleep modes. To sum it up, 5G is an excellent addition to smart pods and should be implemented in Malaysia. It has ups and downs compared to the traditional fiber or Wi-Fi route. However, the future is bright for mobile networks, and the next generation 6G networks shows promising benefits. We are interested in your take on 5G and its use cases in smart pods and beyond 5G technology. Please leave some exciting comments regarding those technologies and we will discuss them further. Thank you.